Hello class, it's Mr. Wicklehouse, and I decided that I was going to do a few more examples with you for graphing these rational functions. Okay. The first thing that we want to do with this is we want to simplify. Okay. So I can simplify this. I'm going to factor out on the bottom. Like so. Come on, stay in focus here. Don't be a jerk. Get it back in focus. There we go. Okay. Well, now I can see that I've got an x on top and bottom that I can get rid of. And so my function ends up being 1 over 4 times x minus 4. And then because of this canceling, then we know that at x equals 0, it's going to be an excluded value because I plugged that in for that. And this guy right here, x equals 0, is going to be a hole in my function. Okay. The next step is to find our asymptotes. So let's find our asymptotes. X minus 4 equals 0, which means that x equals 4 is where this denominator will also equal 0. So this is your vertical asymptote. Okay. Alright, what about our horizontal asymptote? Well, if I look at the degree of the numerator and the degree of the denominator, the degree of the numerator is 0, the degree of the denominator is 1. Or if you wanted to come back here and look at it back here, the degree is 1, degree is 2, which means that my denominator is bigger than my numerator, so I've got a horizontal asymptote. What's our rule? If the degree of the numerator is less than the degree of the denominator, then my horizontal asymptote is at y equals 0. Let's go ahead and sketch them in, the asymptotes. So y equals, or x equals 4, graph this guy in here. That's my vertical asymptote, and then right here at y equals 0 is my horizontal asymptote. We're just sketching stuff here. So now all I really need to know is what my y values are on each side of this vertical asymptote. Are they positive or are they negative on the right and on the left? So what I'm going to do is I'm going to make up this little table right here. And I'm going to pick this value at 4. So I'm going to draw a line down through here. This is x equals 4. And I'm going to pick a value above it. Then I'm going to pick a value below it. I'm also going to look at my hole here, because that's important too. That might tell me something. And I'm going to pick a value below that. Okay. Then all I'm doing is I'm taking this number that I've picked, these test values, and I'm going to plug them in to my function. So I plug 5 in here. 5 minus 4 is 1, times 4 is 1/4, which means that's positive on that side. So over here on this side, all my values are positive. Okay. Now the direction that this rational function takes, it's going to follow along these asymptotes. So over here, We want to be above the y or the x-axis. I'm following down this asymptote, and as I get close to the horizontal asymptote, it's going to start curving away. So that's how that part of my graph is going to look. Now we're going to pick the 3. Okay, plug 3 in. This will be -1. Okay, -1 times 4 is -4. It means this is -1/4, which means this is negative. Okay, which means all the values between here and 0 are down in this part of my graph. Here at 0 is the only thing that I'm concerned about, because my function could pass up through that horizontal asymptote. Okay, so I'm going to try -1. I'm going to plug -1 into this. That's going to be -5 times 4 is -20. So it's -1 or 1 over 20, and that's going to be negative. So these values are negative, which means everything for this whole graph is going to be below. It's going to be below here. So I'm going to follow my asymptote just like that. And there, my function is now graphed. So actually this whole at x equals 0 didn't matter, although sometimes it might. So you need to keep track of those. Okay. Let's look at the next one. Alright. Well, what do we do first? We simplify. So this on top is x minus 4. Here on the bottom, I could factor a 2 out. I can't factor an x out, but I'm hoping that this will factor a little bit. So when I factor the x or the 2 out, I get x squared minus x minus 2. That's going to mean that this is x minus 2, x plus 1. So we don't have any canceling or anything fancy like that to do. But what we've got is a lot of factors here. Okay. So let's identify our vertical asymptotes and our horizontal asymptotes. Where vertical asymptotes occur where our denominator is equal to 0. So I've got x equals 2 and x equals -1. So let's draw those in. Here's x equals 2, and here's x equals -1. Our horizontal asymptote, this numerator degree is equal to the degree of the denominator, which means that I take the ratio of the leading coefficients. So that's 1 over 2. So my horizontal asymptote is at y equals 1/2, which is not quite at 0, right around through there. So there's my horizontal asymptote. Okay, this one's a little trickier than the first one because I've got these values on top. If I've got these x's on top, that means that I have some x-intercepts that I need to concern myself with. Okay. Well, the x-intercept is just where either one of these are equal to 0. So I've got an x-intercept at x equals 0, and I've got an x-intercept at x equals 4. So I've got one here, and I've got one here. Okay. So, let's take a look here. I'm going to go through now, and I'm going to use my table here to figure out where everything's happening at. I've got a lot of values that I'm going to be plugging in here. I've got -1, I've got 0, I've got 2, and finally I've got 4. I've got a lot of values that I have to test here. So I'm going to use 5, 3, 1, -1/2, and -2. All I'm concerned about is whether it's positive or negative. So I plug 5 in on top. 5 minus 4 is 1. 5 here. So 5 times 1, that's positive. On the bottom, 6, 3, 2, that's going to be positive. So on this side, this is going to be positive. Which means that on this side of the 4, I'm going to be positive. Now, let's look at 3. Plug 3 in. Positive. 1 is positive, positive. I'm positive on the bottom, but I'm negative on the top. So this is negative here. Which means on this side of the 4, I'm going to be negative. Okay. Let's plug 1 in. That's 2. That's negative. That's positive. Positive, negative, positive. That's negative on the bottom. Negative on the top. That means this is positive. About -1/2. -1/2, that's going to be positive. Negative, positive, that's negative. Negative, negative, that's positive. I'm positive on the top. And I'm negative on the bottom. That means I'm negative here. Last one. This is going to be positive on top. Plug negative into that. Both negative makes it positive. This is negative. This is negative. And the lights just went out. Hold on. Let's start that one over again. We got distracted by the lights. Negative. Negative. Positive on top. Negative. Negative. Positive on the bottom. Means this is positive here. Okay. Let's put all that together. I'm going to be positive on this side, which means this guy is going to squeeze its way in between, right here, in between this x-intercept and between this vertical asymptote. The rest of this on that side is negative, which means this guy is going to come straight down here, and it's going to be negative. Okay. On the side of this, over here, this is positive. Okay. Over here, between 0 and -1 is negative. Okay. Which means this guy's coming up through here like that. Okay. Now this last part here, everything's positive. No x-intercept over here, which means that the rest of this is going to look like that. So there's our graph. You can always use your graphing calculator to double check yourself, and it might make it a little easier for you to do this. But these are step-by-step ways to do this. One more. Okay. Let's factor this. Factor an x out. X minus 2. On the bottom, take a -3 out. We get x minus 3 on the bottom. Don't have anything top and bottom to be able to do anything with. Okay. So, find our vertical asymptote. Vertical asymptote happens right here. So that's x equals 3. What about a vertical or a horizontal asymptote? Well, there's no horizontal asymptote because our numerator is greater than our denominator. So no horizontal asymptote. None. But we can see that our numerator is exactly 1 degree higher than our denominator, which means that there is a slant asymptote. So let's do our division. Negative 3x plus 9 divided into x squared minus 2x. What do I multiply negative 3x by to get x squared? Well, I'm going to multiply by negative 1/3 x. Negative 1/3 times that is 1. X times x is x squared. There's our x squared. Negative 1/3 times 9, that's going to be negative 3x. I'm subtracting that. Goes away, that becomes positive, so now I've got x. What do I multiply negative 3x by to get x? Negative 1/3. That's going to give me x. Negative 1/3 times 9 is negative 1/3. This is a 0 here, whatever. That's going to go away. We're going to have 1/3 left over. Don't care about that. My slant asymptote is at y equals negative 1/3 minus 1/3. Okay. Negative 1/3 x. Well, now I'm going to take my vertical asymptote. We'll graph that first. Here it is. Bam, 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 bam. That's easy peasy. Now I'm going to graph this. We all know how to graph these lines. A negative 1/3 is going to be around there. And I'm going down 1 over 3, down 1 over 3, down 1 over 3, up 1 over 3. There we go. Here's my line. Remember, this is just a rough sketch. It doesn't have to be perfect. There we go. Got an x-intercept. X-intercepts are at x equals 0 and x equals 2. Okay. Alright, well, with that in mind, let's do our little table. Not quite as many as on the last one. There's 3, 2, and 0. So we'll pick 4, 2.5, 1, and negative 1. Alright, 4 into this. That's positive, positive, positive on top. Negative on bottom, this is negative. Okay, 2.5, that's going to be negative, negative, positive. Positive and positive is positive, this is positive. 1, negative, positive, negative, 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 positive, so that's negative. Negative, negative is a positive, negative and a negative is a positive, this is positive. Okay. So that means on the side of 3 over here, we're in the negative. So this piece right here is going to be right in here. This side over here, we're going to be positive. So we're going to be right in here. There's something wrong there. Hold on. Positive. Oh, that's right. Okay. So 1, up here we're positive. We come down to 2. There's the next intercept. So between that and 1, we're negative. So we're coming down here like this. So it's going to come back up through here and come up like that. There we go. So there is our graph. Isn't that just fancy as fancy can be? Alright, I hope that helps. I know this was a long video, but this stuff is pretty confusing. Take your time watching this and working through it. And I'll do some more examples on the board, maybe Tuesday or Wednesday before we take our test. Alright, I'll see you later.